what we want to look at now is section 8.2, which has 4 objectives. Just like we did yesterday, we want to find exact values with inverse sine, cosine, and tangent. But in this case, we're going to be dealing with things that don't necessarily have a unit circle value. We're going to look at the definition of the other 3 inverse functions, inverse secant, cosecant, and cotangent. We're going to look at how to use a calculator to evaluate those, and that's what we'll be doing most of our inverse secant, cosecant, and cotangent functions. Most of the time, we'll use a calculator for those. And then we're going to find out how to change a trigonometric expression into a completely algebraic one that doesn't use sine, cosine, tangent, secant, cosecant, doesn't use any of those. It just uses algebra. So what we're going to be looking at are the examples that are in the section in the lesson. And so the first thing we want to look for is the sine of the tangent inverse of 1/2. So remember that tan inverse of 1/2 means that we are looking for an angle whose tangent is 1/2. And remember that we're looking for those angles over here in this half of the unit circle. And so you might be thinking, oh no, I can't remember which angle has a tan of 1/2. Well, if we look at our unit circle values, there actually isn't one. Here's our pi over 6, and our pi over 4, and our pi over 3. And I hope you remember that pi over 4 has a tangent of 1 because it's matchy-matchy. It's square root 2 over 2 and square root 2 over 2. This point up here, pi over 6, remember that it has an x-coordinate of 1/2, and then it has a y-coordinate of square root 3 over 2. So when I put that into a fraction for tangent and simplify that, that just ends up being the square root of 3. So the tangent of pi over 6, this guy up here, is root 3. Remember, what we're looking for is an angle whose tangent is 1/2. If I do a similar process for pi over 6, I'm going to end up with 1 over root 3, or if I rationalize that, I'll have root 3 over 3. But either way, I don't get 1/2. And then remember, these guys down here are just the negatives of those. So what I have to end up doing is trying to draw a triangle in my unit circle that's going to help me figure out where this actually is and what the answer to my question is. So because my tangent is 1/2, I'm looking for an angle whose tangent is 1/2. That's positive. And so between quadrants 1 and quadrant 4, that's going to be an angle that sits here in the first quadrant and looks something like this. And remember that tangent is opposite over adjacent. And so because we know that the tangent is 1/2, this is going to be my opposite, and this is going to be my adjacent. And then I can use the Pythagorean theorem to figure out that my hypotenuse is 5. So if you go back to our problem, remember that we're looking for the sine of the angle whose tangent is 1/2. And so that's this angle that we just drew right here. And so knowing that sine is opposite over hypotenuse, the answer to this problem is 1 over root 5, which we can rationalize if we want to. Okay, we're going to do a similar process on example 2. This time we're trying to find the cosine of some angle. Remember that sine inverse of negative 1/3, we're just looking for an angle. We're looking for the angle whose sine is negative 1/3. Remember that we are looking for sine also over here in this half of the circle. The same place we were looking for tangent. Because sine is equal to opposite over hypotenuse, we are going to draw that angle down here. Right, so it's going to look something like that in that quadrant. Let me erase the half circle, get that out of the way. So here's my angle. Sine is opposite over hypotenuse, so that would make this side over here 1, and that would make this side 3. The y-coordinate of this point, that 1, is negative, right? Because we went down. And so again, using the Pythagorean theorem, 3 is the hypotenuse, so 3 squared minus 1 squared is going to equal to my x side squared. And so 8 equals x squared, or x is equal to the square root of 8. We can simplify that a little bit to 2 root 2, because remember 8 is 2 times 4. So my x coordinate here is 2 times the square root of 2. So if I'm looking for the cosine of the angle whose sine is 2 root 2, cosine is adjacent over hypotenuse, and so that's going to be 2 root 2 over 3. Two root 2 is adjacent over 3 is my hypotenuse. Okay. In the next example, we're looking to find the tangent of an angle. And the angle that we're looking for is the angle whose cosine is negative 1/3. And again, that's not a unit circle value. Remember that we look for cosine in the upper half of the circle. And so we know that if our cosine is equal to negative 1/3, then that must be a point that's over here in the second quadrant. So when I draw that triangle, it's going to have an angle that's down here. And since cosine is negative 1/3, remember that cosine is equal to adjacent over hypotenuse, and cosine is x coordinate. So this side here is 1, the hypotenuse here is 3. If we're looking at the coordinates of this point, that 1 is negative. Our y-coordinate is going to be positive, and we're going to again use the Pythagorean theorem. So that's going to be 9 minus 1 square rooted, which is the square root of 8, which is 2 root 2. So if I want to find the tangent of that angle, remember that tangent's opposite over adjacent. Since the adjacent's 1, that's just going to be equal to 2 root 2. I forgot about the fact that my adjacent was negative. So this is actually negative 2 root 2. Okay, so what we do next is we come up with the definitions of secant inverse, cosecant inverse, and cotangent inverse. And I want you to notice here, because I think we didn't pay as much attention to this back in the other section, that when we said y is equal to the sine inverse of x, what that means is we're looking for an angle x so that the secant, we're looking for an angle y so that the secant of y has that x value, okay? So when we said sine inverse of 1/2, y equals the sine inverse of 1/2, we're looking for an angle y whose sine was 1/2. That's what sine inverse means. Secant inverse, cosecant inverse, and cotangent inverse mean similar things. It's helpful if you can remember that secant is the reciprocal of cosine, that cosecant is the reciprocal of sine, and that cotangent is the reciprocal of tangent, because that's going to help us find some of our values. So, for example, when we want to find the exact value of the cosecant inverse of 2, cosecant is the inverse of sine, so we're going to look for cosecant in the same place that we look for sine. And if an angle has a cosecant of 2, that means that angle also has a sine of 1/2, right? So sine is our y-coordinate, so the place where our y-coordinate is 1/2 is way up here at pi over 6. And so the angle whose cosecant is 2 is the same as the angle whose sine is 1/2, and so that angle is equal to pi over 6. In the next example, we're finding secant inverse, cosecant inverse, etc. We're finding those using our calculator. So what you want to do first when you're doing this kind of problem is you want to go to your document button, and you want to go to your settings and document settings, and you want to make sure that your calculator is set in radians. And you want to check that every single time if you're using one of my calculators, especially right now because my functions classes are using degrees, right? If you have an 84, I can show you how to do that on your calculator, but on our calculator, you just have to go to the trig menu, and then our inverse functions are there. I don't know why my program is going crazy there, but if I want to find the secant inverse of 3, this calculator will find it very easily. So 1.231 is the answer that I'm looking for. I know that the book for this one said 1.23, but remember, I always want you to be accurate to 3 decimal places. So you can do those other ones similarly with your calculator. All right, so the last example we want to do is an interesting one. We are going to try to change this expression to an expression that only involves algebra. It doesn't have any trigonometry in it. So the way that we do that is we're going to define, whoops, wait a minute, I lost my pen. Hold on for just a second. Okay, so the way that we're going to do that is we're going to define theta to be equal to the tangent inverse of u, okay? And what that means is, if we take the inverse of that, what that means is that u is equal to the tangent of theta. And we're just going to sit that off to the side, and we're going to come back and use that in just a second. All right, so we're going to, because we just let the tangent inverse of u equal theta, we're going to rewrite this expression as the sine of theta, okay? And then we're going to multiply the sine of theta times cosine of theta over cosine of theta. And you'll get to the point, if you practice enough of these, where you can kind of figure out where you need to go with this. If we put this over 1 and multiply this, that's going to give us sine of theta times cosine of theta over cosine of theta. And we want to group this so that these two guys are together, and then the cosine's off by itself. So then sine over cosine is going to be tangent of theta, and then cosine is the same as 1 over secant. So this ends up being the tangent of theta over the secant of theta. Now remember what we did at the beginning. We said that u was equal to the tangent of theta, and so the numerator of this is just u. Okay? We have an identity that tells us that the secant squared of theta is equal to 1, oh, I can't remember if it's plus or minus. Hang on for 1 second. So secant of theta is equal to 1 plus the tangent squared of theta. Remember that tangent squared of theta is really tangent of theta squared. If I square root both sides of this, then I get that the secant of theta is equal to the square root of 1 plus the tangent of theta squared. But remember that tangent of theta is equal to u. So this becomes the square root of 1 plus u squared, and then this goes into this expression in place of secant. So I get u over 1 plus u squared. So now I can figure out what the sine of the tangent inverse of u is if I know u by simply putting that value into this algebraic expression.